So let's start with those questions. They are from Platinum Maths. Right, I'm going to. There are 4 questions here. I'm not going to do all the questions. Okay, there are more questions. I just took a screenshot of those 4. So let's start with 1.9. Right. So you 0.064 raised to the power of negative 2 over 3. Right. Now you are supposed to simplify this question without using a calculator. You're supposed to simplify this question without using a calculator. So what you're supposed to do is convert that base, which is a decimal, to a common fraction. Right? So 0.064 is the same as 64 divided by, now which multiple of 10 has got 3 zeros? It's 1,000. So that will be over 1,000 because there are 3 digits after the comma there. So the multiple of 10 which has got 3 zeros is 1,000. So all this we raise it to the power of minus 2 over 3. Okay? Then we may need to convert this negative exponent to a positive exponent. Okay? We need to convert the negative exponent to a positive exponent. Right? Now, if you have been going over those stuff, the quickest way would be to swap the numerator and the denominator and make the exponent positive. That's the quickest way. Okay? But someone might ask, how come you end up having such a scenario? So I'm going to show you all the way now. So we are going to use definition number 3. That's x to the power of minus n equal to 1 over x to the power of n. Okay? So this would equal to 1. Remember, our base here is a common fraction. It's 64 over 1,000. That's our base. So this becomes 1 divided by 64 over 1,000 raised to the power of 2 over 3. Okay? Then you can simplify this further. Write it as, now because here I've got 2 over 3 as my exponent, I can introduce one of the 2 definitions or laws that I spoke about yesterday. Remember I said the nth root of a raised to the power of m is the same as, this is the same as the nth root of n, sorry, the nth root of a all raised to the power of m. And that's also equal to, this is also equal to a raised to the power of m over n. So I can use that here. Okay? So what I'm going to do next is I'll say 1 so this becomes 1 divided by the cube root. Okay? Because there's this 3 here. The cube root, our base is 64 over 1,000. The base is a fraction. Okay? So this a here is like the 64 over 1,000. The 2 is like this m here, that m there. And this 3 here is like the n. Okay? So this becomes the cube root of 64 over 1,000. Whatever answer we get there, we square that answer. Okay? Whatever answer you get there, you square it. Right. Allow me to go on to the next page. Okay. Because of space issues. Right? Any question? So, what is the cube root of 64? What's the cube root of 64? Huh? You have got calculators. You can't do it mentally using calculator. It's a 4. Okay. It's a 4. You don't need a calculator for that. You should know. cube root of 64 is the 4. 4 times 4 times 4. So this is multiplying 4 by itself 3 times. You get what? 64. Right? What's the cube root of 1,000? Cube root of 1,000? 10. 10 times 10 times 10, 3 times gives you 1,000. You don't need a calculator for that. So this becomes 1 divided by 4 over 10. But now I have to square that. Okay? Then, once I get here, I'm almost there. And remember, a question like this, you are not supposed to use a calculator. You have to show all you're working on. So this becomes 1 over 16 over 100. Now, your main division line here is this one here. So you have to convert that to a division sign to make things easier. Okay? So if we convert it to a division sign, we'll end up having 1 divided by 16 over 100. The denominator there is a 1. Then we introduce multiplication. And then we invert those two. So the final answer will be 100 over 16. This can be simplified. Okay? Well, there's a common factor, which is what? 4. So I can end up writing the final answer as 25 over 4. That's my final answer. Is an improper fraction. Now, this method that I've shown you, it's a longer method. Okay? It's a longer method. Maybe I'll just call it method 1. Okay, let me call it method 1, and I'll show you method 2, which is a much shorter way. So, in your book, indicate that this is method 1. I need to show you method 2. Okay? So, method 2, for the same question, I'll just write here, method 2. Now, method 2, remember, we have 0.64 all raised to the power of negative 2 over 3. This method now, it is the shortest way, but you can only use it if you understand it. Okay? So this is going to be equal to 64 over 1,000, all raised to the power of minus 2 over 3. Right? Now, you need to know that if the exponent is negative, and you have got a base which is a fraction, as long as the base is a fraction, you can swap the numerator and the denominator and convert the exponent from negative to positive. Okay? Using this rule, you have got it in your books. It's a over b raised to the power of minus n is equal to b over a raised to the power of n. Okay? So I can write this as 1,000 over 64 all raised to the power of 2 over 3. Then I'll find the cube root of 1,000 over 64 and then square the result. So I'll get 10 over 4 squared, which is 100 over 16, and that will give you 25 over 4. Okay. So this is another way of doing the question. If you know that definition. Okay. I have to remind you that the grade level exponents are a little bit complex as compared to what you're used to in grade 9 or 10. Yeah, I don't know about this 3. It comes from the law or definition that I gave you yesterday. The one that I wrote here. I just wrote it. It's the n. That n there. This is the denominator of that fraction. Remember, yesterday I wrote that. And the other one that you were taught in the lower 90s, is the nth root of a is equal to a to the power of 1 over n. So the denominator in the rational exponent becomes the nth root. That's why we put it right in. If it's a 2, we don't write it, right? But it's a 3 or more, then we write it out. Is that clear enough? Thank you. Thank you for asking. Right? So are we all clear with that question? Huh? Okay. So let's.
So what do you mean by 2 or 1?
Okay, when you have, say, if I ask you to find, say, if I say 16 to the power of the half, right? When you write this in terms of a square root, you write square root of 16, but you don't put a 2 there. Yes, because the sign accommodates the 2.
And then even there, we need the 1 because
the 1 now is like this. Raised to the power of what? 1. So we don't need to put the 1. Okay. Okay. I expect you to be aware of that from last year in grade 9. Right, then let me carry on. Right. Okay, because of my time, I won't be able to do all of it. I need to give you some of them. Okay. I cannot do every question. It's not possible for me to do every question. Okay. Let's do that one. Now I chose this one because it's slightly more complex. So I needed to show you how you can approach it. Right? You have to simplify that. Now if you look at the question, you have a radical sign or square root in the numerator. We have got letters A and B. And that minus 1, it's a constant on its own. Okay? It means whatever you have in this fraction, you subtract 1 from it. That's what it means. So your knowledge of fractions here is required. Knowledge of exponents, knowledge of fractions is required for you to do this question. Okay. So since we have a negative exponent there, we have a negative exponent, my suggestion is let's find the fourth root of everything inside the radical sign. Okay? So, what's the fourth root of 81? What is the fourth root of 81? Which number can you multiply by itself 4 times and you get 81? It's a 3. You don't need a calculator for that. So, this is 3. What is the fourth root of a to the power of minus 8? It's like this. A to the power of minus 8. What would be the answer? What's the fourth root of a to the power of minus 8? You can simplify this and write it as a raised to the power of minus 8 over 4. And that will give you 8 to the power of negative 2. You just divide this exponent inside the radical sign by 4. Okay? Just divide by 4 and then you get the answer. So that will be a to the power of minus 2. What's the fourth root of b to the power of 12? I just gave you a hint already. It will be b to the power of 3. So you say, yeah. So don't say it's 3. It's not 3. It's b cubed or b to the power. Then the denominator is already simplified. So we just rewrite it as it is. 1 over 4 times a squared times b to the power of minus 3 or minus 1. Right? Now, it's wise now to convert all rational exponents, all exponents to positive exponents. Or rather, you can just use log 2 of exponents. Okay? So I'm going to use log 2. At the moment, I don't want to touch this minus 1. to avoid unnecessary mistakes, I want to simplify the fraction part first. Okay? Now, 3 divided by a quarter will give us 12. Okay? So you divide the coefficients, you get a what? A 12. Then, since the base is the same here, we can subtract the exponent. So this will be a to the power of minus 2 minus 2. I'm showing you the working out because I don't want to do it in my head. Then b to the power of 3 minus 3. Then we subtract 1.
So, what formula did you use to get the 3 divided by 1 and 4? I understand that but how did you work it out?
It's actually, I would say it's basic knowledge. If you divide 3 by a quarter, this is the same as 3 over 1 divided by 1 quarter. That will be 3 over 1 times 4 over 1, which gives you what? 12. It's just knowledge of fractions. Okay? Then here you get 12, a to the power of minus 4, b to the power of 6 minus 1. Okay, now check this. This minus 4 here, it's a positive, it's a negative exponent. We need to make it what? Positive. So we use this definition. You should know by now. X to the power of minus n is equal to 1 over x to the n. Alright? So that becomes 12b to the power of 6 over a to the power of 4 minus 1. You see that? Because this a to the power of minus 4 is the same as 1 over a to the power of 4. Because of multiplication, it will become a denominator. Okay. Let me try to squeeze it here to explain it here. You see this 12 is 12 times a to the power of minus 4 times b to the power of 6. Right? This a to the power of minus 4, if I use this definition, it's going to become, this will become 12 times 1 over a to the power of 4 times b to the power of 6. Right? The denominator here is 1, the numerator there is what? 1. 12 times 1 times b to the power of 6 gives you 12b to the power of 6. 1 times a to the power of 4 times 1 gives you a to the power of 4. That's how I got it.
So when you done to show that,
Huh? No, I'm showing it because he asked how I got this.
you said you can show one else. So
No, it's not necessary for you. If you want to, you can. Okay, if you want to, you can. There's no problem with that. Okay? Yeah. If you want, you can show this. Maybe you can put it on the side, the pencil or something. And then you can even show it here in more detail if you want. Okay. But thank you so much for asking. Are you following? I'm not done.
Oh.
What I can do here, I can use my knowledge of fractions further. The denominator there is a what? It's a 1. What's the LCD of a to the power of 4 and 1? What's the LCD of a to the power of 4 and 1? A to the power of 4. Okay? So I can multiply this minus 1 by a to the power of 4, this 1 by a to the power of 4. If I do that, on the next page, I'll get 12 b to the power of 6 minus a to the power of 4 all over a to the power of 4. But I'll leave my answer like that. But it's also fine to leave it like this, without that. Okay? Because this has been simplified from where it was. Or rather from what it was at the beginning that has been simplified. Okay? But I'm going to leave it like that. Now when you get here, you can't simplify it any further. You can't simplify it any further. Okay, any question? Okay, if you don't have a question, allow me to carry on to another type of question. Okay? Maybe about 20 minutes or so. Like 3.5. You miss out. Okay, you can go, but you miss out. So 3.5. Okay, 3.5. It requires you to use your knowledge of your laws of exponents together with the rational exponents knowledge as well. So I'm going to rewrite the question. So it's the square root of a plus b all cubed times a plus b raised to the power of a half. Okay? You following this? Now, this question, there's more than one way of doing it, but I'm going to do it this way. I'm going to say this is equal to, I'm going to remove the square root sign. Since this 3 here, it's outside the bracket, when I remove the radical sign, it becomes the numerator of the rational exponent. So I can write that as a plus b all raised to the power of 3 over 2 times a plus b raised to the power of the half.
Mr. Chaponda?
Yes, ma'am?
So I'm terribly sorry, do you mind?
So how do you get 3 over 2?
Because C is still you. Remember what I said? If I give you something like this, you can write this as a to the power of the what? Of the half. With the 2, this 2 here, when it comes to the square root, we don't write, we only start writing when it's a 3, 4, 5, 6, 7, and so on.
So the square root sign, then you check the square root sign, only covering the a plus b.
It's only covering this. Alright? Then, once you get here, it's very important for you to be aware that a plus b is a base, but it's a binomial base. A plus b and a plus b. That's a common what? Base. Since we are multiplying common bases, it means we can add their exponents. Okay? So, next thing is just to write a plus b all raised to the power of 3 over 2 plus a half. That's the half. Then this will give you a plus b all squared. Because 3 over 2 plus a half will give you 4 over 2, which is equal to 2. Okay? Now, we can simplify this further, right? To create what is called a perfect square trinomial, you use FOIL from grade 9. Now, you are in grade 11. Okay? We're taught how to simplify this in grade 9 for the first time and last year. So you need to know that if you use FOIL, you get a squared plus 2ab plus b squared. Don't ask me where I got that. Go back to grade 9. Okay? Use FOIL. Your grade 9 teacher taught you FOIL. It was not in set point. Okay? So, no, that. Okay. Then the other one, that one, let's talk about it quickly before I move on to another aspect. Do you have any question? That's one there.
If you have any like a PDF or something that explains FOIL and just like send it over.
PDF that explain what?
FOIL. FOIL.
But
Some days it says FOIL.
we have to go back to grade 9 or 10. No? But I can send you some stuff on products if you want. Yeah, I can send you some stuff on products. Okay, I'll send it on the group. Alright, so we have x squared minus 6x plus 9 all raised to the power of minus a half. That's what we have. Okay, now this one requires knowledge of factorization. You cannot carry on without factorizing the trinomial inside brackets. Okay, so can someone factorize that? Tell me the answer. Jody, factorize that. What's the answer? No. Oh. 3. Positive 3 or negative 3? It will be x minus 3 all squared. Okay? Right? It's x minus 3 all squared.
Yes, because when you connect to 3 and negative 3, it will be also negative.
Thank you. I don't expect people to be surprised how Mr. Chiponda is getting x minus 3. In this grade, I'm not allowed to teach factorization. Factorization grade 9, grade 10.
I think so. We need to get this grade.
If you decide to teach better, then you will get the top one there.
It's a trinomial.
Oh, yeah.
Okay, unless you don't want me to write it like this.
It's a regular word. Yeah.
Okay. Unless you want me to write it like this. X minus 3.
Oh,
Yeah.
Right? So we factorize the trinomials. But we have this circular bracket and that circular bracket, and that exponent is negative a half. So we need to put a square bracket, then you put minus a half. Okay? What's inside the square bracket are the factors of that trinomial. Okay? But you need to be aware that those factors. No, you're supposed to work with that. Okay. So this becomes x minus 3 all squared. Okay? All this is raised to the power of negative a half. Then I have to multiply now the 2, the exponent which is the 2 by the minus a half. If I do that, I'll get x minus 3 times, raised to the power of minus 1. 2 times minus a half is what? Minus 1. But I need to convert that negative exponent to a positive exponent. Yes? Wanna go out? Huh? Okay. So our base is x minus 3, so the final answer will be 1 over x minus 3. That's the final answer. Okay? I use this definition. Remember, x to the power of minus n is equal to 1 over x to the n, where the x there is equivalent to the x minus 3. The basis is a binomial. You following? Alright, so I'll stop there.